very good, awesome, times the inner function prime, which is
2t.
Very good, awesome. So this would be negative 200t over t squared plus 1 squared. So let's take a moment and think about this. I have 2 times 100 times negative 1, so 200 with minus in front. And all this piece goes to the denominator. When I set a prime of t equal to 0, because this will never be 0, right? So a prime of t can never be undefined. When I set it equal to 0, what do I get for t?
Negative 200? No.
That's a constant outside. When is a fraction 0?
When the denominator is 0.
When the denominator is 0, the fraction is undefined, and it's not the case. T squared plus 1 can never be 0. So a fraction is 0 only when a is 0. A fraction is undefined. I'm sorry. Only when b is 0.
So in that case, the a is 0, so that will make the function t equals 0.
Excellent. So that is the critical number. So now a of 0 is 100 cc. So that is the absolute maximum. They already told us from the very beginning in the problem, it's decreasing. So whenever, as we know this, right, when t approaches infinity, what type of rational function is this? Is it type 1? Is it type 2? Is it type 3?
That's type 2.
Exactly, which means that the limit, very good, which means that the limit as t approaches infinity from 100 over t squared plus 1, we should blindly, don't even look, know the answer. What did we say the horizontal asymptote for type 2 always?
0.
Very good. So we always hope, right, that we take a medication and eventually the medication gets out of our system as time goes by. Maybe in 10 hours, maybe in 3 days, but we really hope that it goes out of our system. Okay. Moving on. Any questions for me? Anything? Stop me, please, if you have any questions. Okay. So we're continuing with 3.4, which is applications. More applications if you want. More applications. There is a C here and an A. And we are talking about absolute max-min. So what is absolute? Here's an example. As we know, know the derivative here is negative, the derivative here is positive, because the slope is negative, the slope is positive, and here's 0. So we always called this a relative min. Same thing here. Derivative is positive, derivative is negative, the slope, of course, here is 0. We always call this a relative max. But for this particular example, the relative max, the function starts here and ends here. I don't have arrows, right? Does not continue forever. This happens to be the relative max, but also absolute max. What does this mean by absolute? There is none other higher than it. Here, I cannot say that this relative min is also an absolute min. Why? Because there is one lower than it. This will be the absolute min for this function. Well, how come it's not relative? It's not relative because it's at the end point. I cannot show the open interval left and right. So this is a relative min because I can show the open interval left and right. The function exists on both sides, but here it does not exist on this side. So at the end point, no relative max min ever. They can be an absolute or nothing. This one is nothing.
Can you scoot over?
Yes. Sorry. This one is nothing. How come it's nothing? Because there is a higher value and a lower value, and it's not a relative because I cannot show the open interval. The function does not exist on this side. So this is an endpoint. It's not the absolute max or absolute min. This is nothing. This is just relative min. This is the absolute min, but not relative. And this happens to be the relative max, but also the absolute max, because there is no other value higher than it. So let's look at a problem, something like 19 on page 314. So we have f of x equals x plus 4 over x, and the interval is -8 to -1. They're asking us to find absolute max min on the given interval. And also, I will add the relative too. Okay. All I have to do is create my table specifically with what I am given. Nothing else. I don't care about anything else. This is the world right now. And this is f prime. And this is f of x. There is no need to go to anything else. Okay. So all I have to do is find f prime. What is the derivative of x?
1.
Yes. And the derivative of 4 over x? Yes.
Square minus 4. How do I factor out the numerator?
X plus 2, x minus 2.
Very good. So when I set this equal to 0, what are the critical numbers?
Wouldn't it be undefined?
We're talking about the critical numbers. It's undefined at 0, but 0 is not in the domain that we are given.
Yeah, that makes sense.
You are perfectly correct to always verify. I absolutely, completely agree. We always should verify the domain.
So if we're only in the limits of -2, I guess.
So what are the critical numbers?
Wouldn't it just be -2 because 2 is not in the
Absolutely.
-8,
Yes,
-1.
so I have to write x equals plus or minus 2. So f prime of x is 0 implies x equals plus or minus 2. And then I'll say only -2 or x equals -2. Correct. Excellent. So -2 and 0. 0. We have to write 0 in f prime for -2. I have to find this number, and this number. So I plug in the function. Very easy. -8. So 4 divided by negative. Let's use the graphing calculator so we cut back on time. Okay, so in y equals, clear and put x plus 4 over x. And we go back to second and table, and I plug in -8, and then I plug in -2, and then I plug in -1. So I have -8.5, and I have -4, and I have -5. That's all I needed. And now I need to study the sign of the first derivative. And I do not need to study the sign of the denominator. How come I don't study the sign of the denominator? I even
Because it's always positive.
It's always positive. Very good. So let's plug in -7. This will be negative. This will be negative. Done. Let's plug in -1.2. Positive, negative. Done. Now I check that these two rows work well together. Not the sign of the function, but just the tendency of the function. From -8.5 to -4, what does the function do?
Increases.
Good. Is that supported by the sign of the first derivative?
Yes.
Perfect. From -4 to -5, what does the function do?
Decreases.
Good. Is that supported by the sign of the derivative? Yes. So here is the setup. I'm not graphing anything. Here is -8.5. Up here is -4. -5 is here. So something like this. This is not the graph. I'm talking about the y values. So what type of point is -8, -8.5? This point. What will it be for this function?
I believe that would be the absolute mean.
Absolutely. Perfect. What does this point become? -2, -4.
Absolute max.
And relative max. Awesome. Absolute max, and I will say in parentheses also relative max. Excellent. What type of point is -1, -5?
Relative minimum.
Not at the endpoint. No relative minimum can be at the endpoint.
Nothing.
Nothing. Thank you very much. Nothing. Excellent. Well done. Okay. Let's look at, we looked at investing last time. Maybe we look at average cost. Any questions on how to find absolute max, absolute min of a function? Do you think we need another example, or is this good enough?
Can we do one more?
Yes. Let's do one more. Okay. Let's look at a, what was this was a rational function. Let's look at a ugly one then. Let's say 25, same page, 314. Since we haven't looked at a natural log, let's look at a natural log. So they're giving us the interval -3/2, comma 3/2. I managed to copy from a different function. I do that a lot. So I'm going to erase that. So this is 26. Okay, so 25. Oh, you know what? I'll keep 26 and I'll just change the function values. They gave us -3. That's even nicer. -3, comma 1. Okay. So 26 again. Natural log of x squared plus 4 and -3 to +1. That's even nicer. Okay. So I start with my table. I will study the. I will determine the first derivative. I will study it. I will study its sign, find critical numbers, of course, before that, and that's it. Done. So from -3 to +1. So we have f prime of x, and we have f of x. Okay. Again, this function exists everywhere. Remember, x squared plus 4 has to be positive, but there is no need to write this because it's always positive. So let's find the first derivative. Can anyone give us the first derivative for this function? How do we differentiate natural log?
Isn't it 1 over x?
Yes, but this is of a function.
So wouldn't it be 1 over x times x squared plus 4
But
plus...
why 1 over x? If the function has x squared plus 4, why would I write 1 over x? You understand my point?
Yeah.
Okay, so let's try one more time.
So wouldn't it just be... So would it be x squared plus 4 then?
That's it. That's what I have. I can't change this. Always
Okay.
cover it. Cover it. Or imagine you're covering it. I differentiate natural log. It's 1 over this times that prime times x squared plus 4 prime, which is 2x over x squared plus 4. So let me write the formula one more time. So natural log of a function prime is 1 over the function times the function prime. That's why I want my students, in general, there is no criticism. I'm just saying this is very important to work with me sequentially, because then if you have to look up each and every formula on the test, you're not going to be able to finish, and then I'll be very worried. Okay, so then f prime of x is 0. Can anyone give us the critical number here?
0.
Excellent. That's it. There is nothing else. Oh. Good. So 0 in there. So now I have to plug in the function, these 3 values. I will put the function in the graphing calculator and plug in -3, plug in 0, and plug in 1. I just thought I put 0 in the wrong spot. That's why I said, oh, and then I realized it was okay. There was nothing wrong. So always carefully make sure that you put the values where they belong. Okay, so here's the y equals. and we have 1 over, what was it, natural log of x squared plus 4. And then just plug in. We are plugging in -3, and then 0, and then 1. So for -3, 2 decimal digits are fine. So I have 2.56. And for 0, I have 1.39 and 1.61. Good. So now I want to study the sign of the derivative. Very easy, because I have nothing to study here. So to the left of 0, what will the sign be? I covered it because this is positive, so I don't even want to look at it. What will be the sign here?
Negative.
Of course, thank you very much. And what will be the sign here?
Positive.
Excellent. This is the moment of truth. Right now, I check whether these two rows work well together. If they don't, I realize that there is an error and I have to start from scratch. 2.56 to 1.39. What does the function do?
Decrease.
Decreases. Is that supported by the sign of the derivative?
Yes.
Perfect. From 1.39 to 1.61, what does the function do?
Increase.
Is that supported by the sign?
Yes.
Perfect. So now we have to figure out what these points represent. And like before, I'm not graphing the function. I'm just picturing what's happening here. I see a 2.56. I see a 1.39 point, and then 1.61. So this is at the height of 2.56, this is at the height of 1.39, and this is at the height of 1.61. What does this point represent? And to be exact, I should write them on the table. This should be just as, so yes, indeed, this is an absolute max. Perfect. What does this represent? And it cannot be relative. It cannot be relative because he's at the end point of the interval. My apologies.
That will be absolute mean.
And relative. Yes.
And relative.
Yes.
Yep.
Absolute and relative min. And that's clear. And what about 1, 1.61?
Nothing.
Nothing, because it's at the end of the interval. Indeed. Would you like to upload